Audio is not coming. Give me a moment. I'll share it again. Apologies.
हमें भारतीय उत्पादों को खरीदने वाले हर एक कस्टमर का दिल भी जीतना। हमारे प्रोडक्ट्स क्वालिटी में जितने बेहतर होंगे उतनी ही ताकत देश की अर्थव्यवस्था को मिलेगी।
बहुत मजबूत नींव स्किल इंडिया मिशन की इस देश में पड़ी है। भारत के इन प्रयत्नों पर भारत के अंदर और भारत के बाहर लोगों का आकर्षण बढ़ा है। रोजगार और उद्यम की सारी संभावनाएं यदि आज बनी हुई हैं तो उसमें स्किल इंडिया डिपार्टमेंट से, स्किल इंडिया मिशन से भी उनका सीधा नाता है।
Hello and greetings of an immersive afternoon once again. I, Sonam Ambe, Chief in Pedagogy at Ethos ESH, warmly welcome all the dignitaries and our esteemed panelists to the Plumb Skill Expo 2021. Today's panel discussion deliberates on MEP design and planning in high-rise, and we have been joined by stalwarts from the field. I would now like to welcome Mr. N. Rajiv, who has passionately conceived and curated this series with international speakers. Rajiv would be the moderator for today's session. He is the director for Indian Plumb Skills Council, the national vice president for Indian Institute of Interior Designers, and the ambassador for the International Federation of Architects and Interior Designers. Professionally, Rajiv is the stakeholder, a shareholder, and MD of Spanish multinational EPSA for Middle East and SAARC region. So without much ado, over to you, Rajiv.
Good afternoon, viewers from IPSC, headed by our respected chairman, Dr. K. Somani, Fiki, panelists and friends of the plumbing fraternity. I hope I am audible.
Yes.
It's day 4 of the Plumb Skills Expo, inaugurated on Wednesday by our Honorable Minister for Skilling, Dr. Mahendranath Pandey, and continues for a month. We have nearly 120 registrations from the plumbing field, roundtables, local seminars, B2B meetings, and the whole spirit and the whole movement of plumbing is on a forward path. Mission of our Honorable Prime Minister, Mr. Narendra Modi, to make India a global plumbing hub is our mission in IPSC with skilling, placement, and trade for the plumbing sector. Coming to the seminar in this world of mega tall and super tall buildings, with 2 of the super tall buildings, one in Dubai and one exactly 601 meter in Mecca. It's a great subject, except that I have a problem. Normally, moderators are supposed to be the experts in the subject, but today I'm with 5 panelists who are so well versed in the subject that I'm already not feeling very comfortable. I hope I have the energy to continue this further. Of which 3 of the people from Dubai, I would say it's relevant to the subject, has been my mentors in upskilling my knowledge in plumbing. So with not much conversation, let me go to the task of introducing the panelist and we get going. We will be having each panelist to speak for 4 minutes on the subject, which I will be explaining now. And we will have 11 minutes to 12 minutes of discussions based on the panelist, with between the panelists and also with the audience. The point here is that yesterday we had a very relevant subject, MEP versus architecture. There were a lot of views exchanged and there was a lot of deliberations. The conclusions, of course, such a big subject cannot be arrived, except that we understood that there should be a common platform for sharing between the architect, the MEP consultant, the project manager, and the contractor. Today, we hope we are able to get more conclusions towards this session. To the panel, let me welcome Mahendra, who is one of the oldest and tallest individuals in MEP industry with 40 years experience in the Gulf. He doesn't look that old. He's an avid cyclist. I would say his whole life was based out of Dubai, contributing to the plumbing industry. Currently heading the MEP division of Built Middle East, Mr. Mahendra is an REC Bhopal product. To wrap up Mahendra's profile in a short time is a bit difficult. You see on the screen the major projects he has been involved in the skyline of Dubai. To name a few, Marriott Marquis, Address Jumeirah Gate, which both have records to the name, and the tall hotels like Burj Vista, Hyatt Regency, Grosvenor House, Ritz-Carlton, and most of the Lee Meridians are done by his company. He has done some high-end boutique hotels like Al Mahar Resort, which you see down, and 101 Royal Mirage. Villas, he has done thousands of villas like the Arabian Ranches, Dima 1, Dima 2, and he has also been the MEP for the Grosvenor House. Mr. Mahendra will be talking about the flow of water, the upstream and downstream flow of water in high-rise buildings. That will be the subject he will be addressing. Mr. Firaz Al-Nijar is a director of a leading group in Dubai called Jumal Majid. We never stuck a chord in the first couple of meetings because he was too technical and I was a little bit zero technical. But finally I said the difference in our character made us friends. And he is one of the most experienced and senior professional in the MEP industry with 25 years experience, spanning from the ruler's office to MR and now this famous group. He has been responsible for many of the iconic projects in UAE like the Opera, Dubai Downtown, the Dubai Mall Extension, Address Dubai, Marina Tower, Burj Nahar, the list goes and goes. He's a specialist in firefighting systems, chilled water plants, energy transfer station, and civil works. It's a pleasure to welcome Mr. Firaz. Mr. Firaz will be touching on the subject of risk analysis in plumbing systems. I have Mr. Anbu, who is a part of our skilling landscape too, because he's taking classes, he's doing some projects with REC Rourkee and Chhattisgarh government. He handles a company called Pro Lead Engineering Consultancy. He's 35 years here with 30 plus years in the Middle East. Lead accredited professional from US EPC, ISO 50001 lead energy auditor, and a member of ASHRAE, AEICC, and whatever you name it, he's there. The founder member of the UAE Society of Engineers. It's a pleasure to welcome Mr. Anbalagan. His projects are also shown here. He's worked with leading groups like Atkins, Arapec, Mary Associates, and he's into his own business for the last few years. Mr. Anbu will be touching the subject of hot water return in high-rise buildings. With a panel of the Dubai-based panelists finished, now let me move to Sandeep Roy Chowdhury. Sandeep Roy Chowdhury is a science graduate and a qualified cost accountant and has done his master's in business administration. From the non-banking sector, he joined his family business as director of Sanitary Syndicate. Under his able leadership, the company has executed various landmark projects, not only in sanitation, but in various other structures he has worked, like the fire detection, air conditioning systems. To name a few of his projects are namely the Wipro Calcutta, Bhubaneswar, Taj Gateway, Novotel, Swiss Hotel, the 42, which is the tallest residential tower as of today in India. Under his leadership, the company has undertaken projects ranging from the tallest tower of Calcutta, airport green buildings, etc. Welcome to this forum, Mr. Sandeep Roy Chowdhury. Finally, I have with me Mr. Sandeep Goyal. Mr. Sandeep Goyal is from Calcutta, from Delhi. Give me a second, I missed his page. Sorry for the small delay, sometimes this happens. The projects of Mr. Sandeep is what is visible on the screen. And Mr. Sandeep Goyal is the founder director of ProEon Consultants Private Limited, an MEP consultancy company and a partner of ProTech Fire and Life Safety Consulting Company. Sandeep has been engaged in the building services consultancy with over 25 years of working experience. Sandeep has contributed significantly in various disciplines of building service design and in codes. Sandeep has worked towards the revision of National Building Code of India in 2005 and now the 2016 edition. He is to his credit and contributed and led in design services of HVAC, plumbing services, electrical services, fire, life safety systems. He has been visiting faculty at SPA New Delhi with over 15 years of contribution towards imparting lectures to young students. And he is also representing India in the Tall Buildings Association and the board member at the Untitled Chapter. Both Sandeep Roy Chowdhury and Sandeep Goyal, both are directors of our Indian Plumbing Skills Council and have contributed considerably towards the plumbing ecosystem. With this introduction, let me now move on to Mr. Mahendra for the first session. Each session, as I said, would be for 4 minutes with 10 to 15 minutes of discussions. And finally, we'll have a conclusion for the last 15 minutes. Over to you, Mr. Mahendra.
Hello, good afternoon to all. Like Rajiv has said, I would be touching the subject of effective domestic water upfeed and downfeed systems. The biggest challenge in super tall buildings, we tend to have 3 to 4 service floors with intervals of 75 to 95 meter high, where the pump heads can be 8 to 15 bar. And if these pumps are not controlled well, you can have a huge water hammer and the piping can get damaged. You can have blowouts. So what I would recommend is when you select your pump, you can go to the curve. When you select a pump, here you end up because of high head and low flow, vertical multi-stage pumps. For example, there is a typical pump selection done for one of the towers in Dubai, where it is required 8.3 bar head and with at approximately 2 liters per second. You can see the close valve pressure hitting 13.5 bar, which is nearly 50% more than the required head. You can take the slide off. So what happens is when the pump stops, you have a water column of 85 meter, but then there is sudden dynamic head of 135 meter. So this blows off the pipes in the lower region of the shafts, sorry, the risers. So what we have to do to prevent this? To prevent this, we need to have an effective control of the stops and stops of the pump. And this can be achieved by delayed action float valves, where you can see it in the figure, where you can control, there's a valve controlling two sections of a tank, which are interconnected. And you can either have it half filled and then take it up. So normally you take 30 to 45 minutes to fill a tank. By half, it may be 15 to 20 minutes. So I will not go into the explaining you how a delayed action float valve works. Anyone, you can find out from the catalogs of these manufacturers. But then this would help in reducing the pump starts and stops. And second is the pump, when it shuts, we do not want the pump to suddenly shut. So we want to bring the stoppage slowly. And this can be achieved by putting VFT drives in the pump controller, where you can ramp down between 30 to 45 seconds the cutoff of the pump, which can also cut down your water hammer. Thirdly, the non-return valves, we would recommend to go for a non-slam one, which is shown on the slide 3. Wherein it's a spring-loaded one, so it doesn't clatter and as the pump slows down, slowly it ramps down, even the valve also will accordingly respond. And this totally cuts your water hammer, and you can have a very, very smooth start and stop of the up feed system. And we have achieved in many tasks, and it's working fault-free for many years. Then I come to the downfeed lines, which is much more simpler. Basically here, you should not have pressures exceeding 5 to 5.5 bar. So you achieve this by having PRVs. So one has to correctly size the PRVs based on the flow and ensure that it is also taken care, the low flow bypasses are taken care in these valves, and pressure relief valves are also given in the downstream. So if there's any questions, I can answer.
Mahendra, we have touched the subject very well for upfeed and downfeed, stressing on the selection of proper selection, addressing water hammer, effective start and stop, and for the downfeed, not exceeding 5 bar and the suitable PRV. So the basic factor of the design is covered. Now we have 10 minutes for questions, or we can move to the next session.
Mr. Mahendra, this is Bala here. What would be the optimum velocity of water which is required in the pipe for pipe selection?
See, for the optimum sizing of a riser pipe, we generally go at 2 meters per second, where the friction losses are limited to 6%. Generally, consultants go down to 1.25 to 1.5 also, but as a contractor, I won't wish for that because you go for a larger size of piping. It's not really required to go to that levels. A 2 meters per second is good enough, and it stays within 6% friction losses.
Okay. I have one more clarification required. With regards to the pump selection, basically, most of the time we can see on a high-rise building, people talk about 3-duty, 4-duty standby, identical pumps. Okay. And also perhaps one pump set for the whole tower. What is your experience, or say that whether we should go for a multi-zone pumps on a high-rise building, or we should go for unidentical pumps based on the demand, and we should be run on VFD? I hope I've given a, yeah.
You given, okay. I will take it the other way around. There are two types of pumping system. One is only transferring water to the tanks on the service floor. The other thing, what we call in India, the hydropneumatic pumps, which directly pumps into the apartments from the basement into the upper floors. So the multiple booster sets are very good if you're going to have directly pump it into the apartment of various levels without having a service tank. That means there is no gravity feed. Because that way what happens is the peak and off-peak demands, they vary a lot. So based on the demand, the pumps keep coming one after the other, and you have a flat system curve. But as for the downfeed system, you don't need to have a multiple pumps. You can just have a duty and standby.
Okay.
And it's always preferred to have a VFD drive because the curve is flat. You will not have surges, extreme surges. You can avoid quite a lot of water hammer, and it's also energy efficient. And with today's technology, the drives are not expensive. And Rajiv's been tuned in to give good prices for super tall because he wants his name to be there.
Till now, I'm yet to get a good price. Apart from that, everything has been achieved.
You got big names, man.
Sandeep is laughing. I think when I said price, he wanted to say something.
I'm just saying that you want a good price because of at least you can demand because of the weight of the equipment which you sell. As consultant, we sell in grams. We can't even expect pricing as a matter of fact.
My God, I rest my case. I think Suresh was raising a hand. You wanted to ask something, Suresh?
Nothing. I think I just.
Okay, Suresh is the country head of Voltas. And I forgot to introduce Mr. Balagopal. Balagopal has been in this Middle East for the last 30 years. Again, an MEP specialist based out of Dubai. The panelists have any question to each other addressing the subject of upfeed and downfeed? All of you being professionals, I think there is not much of a debate on the subject except the need that it is necessary. And
Yeah, I recommend VFDs for both transfer and booster sets.
But why for transfer? Because we are filling the overhead tank, no?
What the whole thing is started that way. You can limit your ramping down. You slowly shut off the pump so that you don't have a hammer in the riser pipe.
In fact, Mr. Rajiv, when you're doing multiple towers transfer, then there could be a demand from few towers not coming and few towers are having the demand. So if you have a VFD, the system gets more synchronized depending upon the towers which it is filling up.
If you have 8 to 10 tanks on the top.
Yeah, that's right. So let's say there are solenoid valves of 3 tanks switched off,
Yes, okay.
Your demand ramps down.
That's the reason I was saying go for delayed action float valves.
That's right, sir.
They are extremely good and they are very, very reliable, unlike the float valves and float switches.
That's right, sir.
Mr. Mahendra, I just want to ask one more clarification. What is your opinion of providing a jockey pump on a VFD-driven set for a very low flow demand?
You don't need a jockey pump technically with a VFD-driven pump because it can start off with 15 hertz.
Yeah, naturally it's 15 to 18 hertz. Yeah, you're right.
Technically, but sometimes consultants do put in a jockey because it's copy and paste. You don't need a jockey for a VFD-driven pumps.
What do you mean copy and paste of the specs?
Specification.
Okay.
In older days, you did not have a drive, so you had a duty standby, and to take off these low flows, you used to put a 10 or 15% size jockey pumps. And they used to work on pressure switches. Today, they are on pressure sensors and drives. You don't need jockeys.
Do we need a pressure vessel?
Pressure vessel is required to take care of the expansion. Again, it also helps in pump start and stops.
To prevent multiple starts and stops.
So, no, my question is in that case, what would happen if it is a VFD system? Anyway, it is ramping up the system for the slow demand. So how the pressure vessel would act into the system?
Because water is non-compressible. So you would be needing a pressure vessel. Also temperature fluctuations, expansion, contraction of water. So it's better to have a pressure vessel. Doesn't cost much.
No, I know it's not a question of commercial aspect of it, but instead of the technical aspect of it, I asked because I can see several consultants are asking for pressure vessel. At the same time, there's a question coming up like why we need a pressure vessel in a VFD system. Yeah, I got it. I got your answer. Yeah.
But you need, Mr. Mahendra, I would also say from our side of working, you have to provide a pressure vessel and be careful of not to make it too large.
Exactly.
Otherwise, VFD is not able to speak to the demand.
Yeah.
So it has to be a pressure vessel reasonably small.
For a smaller demand.
Otherwise, the VFD will not come into picture. Yeah,
That's right.
the pump will never start.
Yeah, because they'll not be able to synchronize with the demand pattern.
Yeah.
Sorry if I can participate in the conversation, Mr. Rajiv and Mr. Mahendra.
It's perfect.
Thank you, Mahendra.
Thanks, yeah, thank you.
We have got some questions.
Questions in the chat box as well.
Sonam, you can upgrade Chintan to the panelist.
Yes, yes.
I've got a question from Aniket Chakravarti, but I don't understand the question. It says design criteria in high-rise building for good performance, like zones.
Varun had deciphered it for me, so maybe Varun could unmute and or I could do that. So it basically says that in high-rise buildings, what is the criteria to divide into zones for optimal performance?
Okay, service floors.
Basically, service floors, maybe Sandeep sir can even explain it better. It's drawn by the life safety systems. Because generally the NFPA or even Dubai Civil Defense Code, they don't exceed, you can't have more than 90 floors. Sorry, 90 meters, I'm sorry. Yeah? So that when the fire pump starts, it all starts with the fire pump. It doesn't exceed the 17.9 bar. So they limit it to 90 meter head. And it's followed everywhere in the world. So because of the fire, life safety, the service floors come in, so domestic water follows that.
Perfect.
You can further say anything, Mr. Sandeep?
No, I think that's right, sir. Actually, that system also requires pressure balancing zoning. Specifically, in our case, the hydrant pressures should not be too large to avoid the accidents to firefighters. So therefore, over there, for life safety purposes of the firefighters, also the zoning has to be highly, engineered.
Just I want to add one point for this, the criteria which is being limiting to 25 bar as per the NFPA requirements. And they take that 20% as the closed valve head, for a pump curve. If you're going for a flatter curve on the selection of the pump, you can probably edge it a little bit more. I mean, to reach within the 25 bar. That 17.9 bar, that's the one which is that 90 meter, the height of the building, which is driven by that. And if you can select a slightly better pump, if your building is just about 95 meters or 100 meters, you don't need to go for another intermediate floor, because that way we have gone for some exemptions in that 17.9 bar, but NFPA pumps cannot be, certified, if it is beyond the 25 bar. So yes, the criteria that 17.9 bar can be stretched a little, maybe for 3-4 floors. 10 meters, 10-12 meters, you can just add on to it. But still, the intermediate floor is mandatory from a fire perspective. And also, we try and achieve kind of the uniform pipes and fittings, like PN16. If you exceed the 100 meters, then you need to go for a higher pressure rating for the pipes and equipment. That's another criteria which drives this intermediate flow.
Anbu, there's a little deviation here.
Yeah.
All for the life safety systems, we are again deviating. They have to be listed valves. Whatever valve you use there, they have to be listed. And they're all 300 PSI, that is 21 bar. It's not 25 bar. And most of the pumps are end section split case pumps, what we use for the firefighting, where it's flat curve, where they're not as steep as the vertical multi-stage. So most of the manufacturers, not all of them, there are good manufacturers who can give a pump with a working this thing of maximum 17.9. It doesn't, closed valve should not exceed 21 bar.
Got it.
So
yeah.
They try to keep between 5 meters to 90 meters. You generally have a service floor in super tall buildings.
Sure. Yeah.
Sure.
Sonam, we have a few minutes left. Would you like to address the other questions?
Yes, there are a few more questions. Most of them are interestingly from Mr. Suresh Kumar. So he could actually unmute himself and ask the questions directly.
Or you couldn't decipher the questions.
Yeah. No, I think okay, fine. I think we are talking too technical about the plumbing system and everything. The fundamental fact remains that the plumbing is one of the field which unfortunately neither mechanical nor civil, and it needs a lot of deliberations on the high-rise building design as well as the supporting system pattern. I think if I look at the kind of leaks which have taken place in Dubai in the high-rise buildings, and especially recently I was getting involved in some of the US high-rise building problems which construction contractors as well as the developers face, I think this is a fundamental issue. I think this need to be addressed. I request the panelists definitely during your course of your deliberations, I think you should touch upon it. And that includes the knowledge sharing, learning from the mistakes which happened in the industry across the construction segment. I think I'm sure the panelists should address it, and I think it's a major concern today. I think pushing many MEP contractors into a big question, big challenges, which unfortunately not spoken outside, but it's a hidden problem.
Well noted, Suresh. Sonam, any other questions you can see?
I think we can move to the next panel. We'll circle back to the questions.
Yeah, there was one question about some valves related to the subject. If you go up.
Yes, so why ring main? This question is by Mr. Bipin Dubey. He asks why ring main line is required in water supply and not single T connection.
It equalizes the pressure. A ring main equalizes the pressure. That's the reason they go for a ring main.
Thank you. I think that answers your question.
Redundancy.
So I think
Tap off. The redundancy is there.
If the ring main breaks, you can actually still isolate and still make sure
That's the
water supply
redundancy.
goes. That's right. That's right.
Chetan Seth from Mumbai. Request to explain, Chintan, sorry. A request to explain about the position of installation of hammer arrestor to get optimum results.
The water hammer arresters generally installed inside an apartment where you have a quick closing valves, like if you have a dishwashers or washing machines, where it suddenly stops. So you generally install on the end of the line where these are tapped off. That is inside the apartment. And when it comes to the main risers, it has to be closest to the location in the lower part of one of the arresters should be in the lower part of the riser and one in the topmost. By using the simple methods I've told you, you will not have a water hammer problem at all. By ramping down the pump slowly, go for a non-slam check valve and go for delayed action float valves. You would totally eliminate water hammer in water supply, the riser valve.
Perfect. I think we had a small but wonderful session. I think this upfeed and downfeed, I think it's been well handled. Very well presented. The questions, I think it's clear now. Now let's move to Mr. Anbalagan. He's going to talk about a very interesting subject, not but addressed, the hot water return in high-rise buildings. Over to you, Anbu.
Sonam, you'll be.
Yes, if you would want me to, I'll do that.
Okay, you can. Yeah. The first, in terms of the hot water system in high-rise buildings, first point is that you can do it in different ways. Either, like you can go for individual floors, hot water, you can have a centralized hot water system on the respective floor and distribute internally. that's based on the pressure zoning, which is already taken care in the cold water supply. So, like we talked about, either you can go for an upfeed system or a downfeed system. In high-rise buildings, when we talk about it, so you will be going for intermediate floors, which is with a separate tank, and which will be feeding the lower floors with gravity and the upper floors with the boosted pumping system. In such case, you can go for the respective floors. You can go for centralized hot water system. We have done for a 35-story building, not a very tall building, but still it's about 110-meter plus. So in which we had a plant room on each floor for serving the apartments in that floor with hot water, which was perfect because but there was a floor space which was compromised. So we had to just do that. And it's a very good system. Though it's a high-rise building, because of the pressure braking, which is already taken care, you can go for the respective floors, the hot water calorifiers, and which are small in size and which is very easily manageable. This is one of the things which I've done in a high-rise building. But typically, what happens is you need to go for either boilers on the lower level or intermediate level, and with calorifiers which are distributed in intermediate floors for serving the floors above and below. So in such cases, one of the main problem is the pressure balancing of the water until the fixture point. So we had a specific case which I'll just show where we had problem with the hot water, the pressure balancing and the return. So which is to be taken care in the location of the pressure balancing, the PRVs, which is to be taken care in on the risers as well as on the distribution lines. Then the next is the temperature balancing. Here again, there is a huge difference when it comes to the hot water return, which comes back to the calorifier, and also the time it takes for the tap off. In case of a long horizontal run and even vertical rises when they are long, and if you do not have sufficient hot water return, then at the delivery point it takes much longer, than what is desired. Particularly if you look at high-rise buildings with high quality the lifestyle and living, and also for hotels, 5-star hotels, when we talk about, they need hot water at about within 10 seconds. That's an acceptable time frame by which you need to get the hot water. The longer you take, it is going to it's a waste of energy, and also it's a discomfort which is not acceptable. So how you balance this temperature, that's another the point which needs to be taken care in high-rise buildings. Yeah, please, next slide. And if this temperature is not managed properly, you tend to get water, high temperature water returning to the cold water line, and there is a possibility for scalding. So this has to be avoided at all costs in high-rise buildings. There are the simple measures on the fixtures itself. You can have non-return valves on the cold water line to prevent any hot water returning into the cold water side and having any possibility for scalding. So this needs to be addressed in the high-rise buildings. Then the last one, which I'm talking about, is the Legionella stratification, because now the calorifiers which need to be maintained at 60 degrees centigrade at all times, because if it is not maintained, then you tend to have Legionella development. And how this is to be done is again by using this thermostatic mixing valves and running the return pump periodically, and to ensure that the boiler which is supplying the hot water or the direct heating the main calorifiers, it should be kept on, so that you maintain 60 degrees centigrade within the calorifier and on the supply. So this is also an issue which needs to be taken taken up and addressed during the design and during installation for, Legionella, to avoid the Legionella development. Please. So the main thing is the pressure rating of the equipment and the pressure zoning. This needs to be done, which has been covered on the cold water line, and the same thing applies to the hot water. We need to have intermediate floors wherein the calorifiers or the hot water, central hot water distribution, the equipment are kept, and ensure that the pressure rating of these, the vessels, the piping, the fittings, everything has to be taken care in the in the selection of the equipment and materials. Then the decision on the upfeed or downfeed and the plant room arrangement, this needs to be taken care. And the location of the PRVs and thermostatic valves. These are extremely important in terms of maintaining the pressures and the temperatures on the circuit. The other point, which one of the things which Suresh was just talking about, the expansion contraction compensation, or the piping arrangement and the support system and how it is to be taken care, that needs to be a proper study to be done, and you need to have the installation done on the risers, the proper the contraction and the expansion contraction compensation needs to be addressed. Then one of the points which we just take care in high-rise buildings is to have maybe more number of risers internally and to minimize these horizontal runs. One is to minimize the heat loss, and to have this return water system kind of more efficiently done. Yeah, you can go to the next. Earlier days, the hot water return, the piping sizing, it used to be kind of, we have seen it, it has been just done randomly, but now we need to do the hot water, the return piping, the volumes and the heat loss, which is to be estimated correctly for sizing the piping as well as for the hot water return pump. This we had experienced in one of the projects on a high-rise project, wherein we had to go back and change the hot water, the return pump, because it was undersized, and we had been having serious problems in the water delivery, which was taking too long a time. And so in this, we need to have the right selection of the boilers as well as the calorifiers, the demand calculation which is to be done in standards, as per the standards, and also as per like the standards which are defined by the different hotel operators. So we need to be careful about this. And in high-rise, this is a very critical point to take into consideration. Yeah, next slide, please. So this was a case study which we had done this, and the most of the points which I just talked about, we had faced in this particular building, and which we have resolved it by going for additional PRVs and also the changing the hot water return pumps to get the correct pressures and also the temperatures at the final outlet. Yeah, you can. Next one. Yeah. So that's it. I think I've covered the point which is related to the hot water system as a whole, and the issues what we have in terms of the pressures, the hot water returns, if it is not taken care, the related problems of what you have in high-rise buildings. Yeah, next. So this is initially we did not have, this is a, during the initial tender design, this is what was installed. And we had not, I think we can go to the subsequent correction, what we have done. Next slide. We had to add the PRV stations in between on the risers to get the pressures within the 0.9 bar range, which was not existing in the original design. And that was, that managed the pressure. And this is one of the things. And we had redone the calculation for the hot water return side and changed the pump, hot water return pump. Yeah, that's it. Thank you. Any questions?
So, Anbu, thank you very much. You have touched the subject in such a short time. Pressure balancing, temperature balancing, safeties in scalding, Legionella stratification, pressure rating importance. Most of the subjects have been touched, like the hot water demand calculations, the hot water return pipe, and hot water at time in hotels and everything. So thank you very much, Anbu. And I think it's a very, very valid subject in today's context. So let me open it for the panel for questions.
Anbu, can you just throw some light on the type of materials and the type of valves which are needed to be used? Because I think while the designs can be resolved, I think the challenge still seems to be the availability of material, and especially when it gets into the PPR, etc., with the temperature derating which is taking place at, see today 60 degree happened to be a very challenge, and I've seen you're mentioning about 70 degree occasionally. I mean, these are all challenges which I think on the practical front of it, from the FM side of it. Can you just throw some light on it?
See, earlier days, copper was used as a material which is for the hot water lines. And subsequently, if you look at it, most of the buildings, they are replacing copper because of the corrosion, scaling, and things which is one of the major issues. And many of the high-rise buildings, we have seen rises, the entire piping being changed from copper to a non-metallic pipe. So what is available? What is an alternative material? Traditionally, because of the PPR availability and which can withstand the temperatures and pressures, so people have been opting for PPR. But on the risers, you need to go for either stainless steel, because of the higher pressure which it can withstand. But nowadays, even PPR risers are being done. One of the problems what we had with PPR is that the inconsistent quality and the fittings which had been coming, they had extremely, though it's from the same manufacturer, we had issues with the fittings cracking, and we had quite a few leaks because of these. I would say it's not the material itself, but the spurious and plenty of materials which have come into the market, which has damaged the reputation of PPR. So what is the alternative to PPR? You need to go for more expensive materials in terms of ABS, high quality PVC, or which may be more expensive. So people are still tending to PPR, to choosing PPR as an option because of the cost. And within the rings, which within the you go for Pexalpex, which is it's a multi-layered piping which is used for the hot water lines. And the final drops, people have been using the PEX pipes in pipe system so that you can replace it. So this is broadly, I mean, like the materials, yes, currently PPR is being taken as one of the safe option, I would say. Other options could be the more expensive ones. So even as a contract, even if we specify something, sometimes as consultants, we put in materials and people come back and say an alternative material which is going to be cheaper. I mean, because which has been broadly accepted. And the failures, in my opinion, have been mainly due to the, I would say, wrong sizing. Could be because of when you talk about the OD, ID, and the nominal thickness, people tend to use the wrong pipe sizes, which can cause the other issues in the selection of the material. So currently, the way we are looking at in many of the high-rise buildings also is that PPR for hot water lines is being considered as a safe option. Maybe Mr. Sandeep, Mahendra, you're muted.
On the material side of it, Mr.
Sandeep,
Yeah, on the material side of it, for buildings which are central hot water, generally we face in India, most of them are hotels. Residential buildings in India are not central hot water, as well as hospitals are not tall in India. Because our hospital limitations are 30 to 45 meters. So on hotel buildings, like we are doing in one in Sri Lanka, Colombo, the height is 230 meters. There we are using stainless steel risers because we need to provide the right type of joints for the hot water. And there is where we have to make a informed judgment, because a plastic pipe has lesser pressure rating on higher temperatures. So one has to take, I think a value engineering approach has to be done, that you have to use the size of the nail, what it requires at what location. So maybe the riser works out very well. And I am very careful about the hot water return head pump pressures. So when you have a very tall building, and if you do not specify, Mr. Rajiv's expertise lies in the pumping segment, if the volute of the pump is not good to receive the high head pressures from the static of the building, you may have problems within the volute of the pump as well. So one has to be careful that the pump heads are not very high in return, but the volute head pressure is pretty high.
I will also see, I have an objection to use any of the plastic piping for large hot water return pumps.
That's
Piping.
right. That's right.
It would work because generally this PPR or CPVC, a continued temperature of 70 degrees, 60 degrees, they don't work. They tend to leak. The life is very, very, very less. It gets reduced. The 50 years what they give in the catalog is not applicable. Still,
we are generally at about 50 meters, 45 meters.
Best material, because in a hot water piping, you don't chlorinate the pipe water. When it goes to the boilers, you take off the chlorination, it goes into the softeners. So the copper piping should not get corroded. If the hot water system is properly designed, and never go for PPR, Suresh, with a large return piping. Copper is the best and cost effective compared to stainless steel.
But copper is being replaced. I mean, we have seen in almost many.
This is what I'm telling. The reason copper is getting replaced is because of chlorine.
And air entering into the system.
Most of the hotels, they're putting the chlorine, but this has to be dechlorinated. You need to have filters before going into the boiler. You don't need to chlorinate hot water.
That's right.
That's the reason you use 60 degrees, the Legionella, this thing.
It's good, two sides of the coin. Firas, I think you wanted to say something on this.
Yes, actually, I need to talk about the water material have corrosive inside the water. If the water don't have oxygen inside the water, starting sharing the oxygen through the material. If you use plastic or PPR materials, it will not corrode the pipe, or use it any material, stainless steel or copper. If your waters, like Dubai waters, it's very high corrosive. To maintain this is material or waters, have to add some chemical inside the water to avoiding corrosion within the pipe. And this is material is very expensive. Why we need to use PPR to avoiding any corrosion within the pipe? Okay, fine. We can use the stainless steel pipe in the hotel industry only, or vertical pipe continuously use the water. If the water snagged in within the waters or like closed loop, the pipe will corrode it 100% if you not added the chemical. This is corrosive of the waters. It's very, very important, not hardness. I'm talking about corrosive water. It's coming as oil. If you're touching the water, it's coming like as oil. This is corrosive of the water. Make it water analysis for the waters. Check how much the water corrosive. After that, you can select which type of the pipe I need use. Another issue now in the technology and the pipe, you have HDPE pipe, can use it for hot waters, or you multi-layer pipe. Multi-layer pipe can reach until 9 bar at 100 degrees. Now in Italy can use this multi-layer pipe, or in Saudi Arabia now, metal pipe with PVC coating. It's available now in the market.
I like to ask one question to the panelist. There is a technology which has come in. I came across the catalog. I have never used it. It's known as hydroflow. it decomposes the calcium carbonate that forms the scale in the pipeline through transmission only, and breaks the calcium carbonate, and all the calcium carbonate that is formed, it get descaled, and it comes out from the open water tap or any other outlet. Have you come across to this technology ever? Or you can check the YouTube also. Somebody came to me with this technology. I have never used it, and I want to ask from the panelists. It is a UK-based company who have just come in India.
I have come across, sir.
Okay, it's good. It's commercially viable. I see some benefit of it.
It's a hydro. It's a name of the company. It is a technology of that company.
You can share the link. We'll definitely have a look at it.
Yeah, I will share. I'm sharing that link in the group just now.
I would like to welcome two lead MEP consultants from India. We have Mahendra MK Gupta, who is also our board member of Indian Plumbing Skills Council. Welcome, MKG, sir.
Welcome, sir.
Yeah, Rajiv, I have a question.
Let me just finish 1 second. Yes, I was just coming to you. The second MEP consultant I was going to welcome was Mr. BSA Narayan from Maple. So welcome to both of you, and over to you, BSA.
Yeah, I have a question to Mr. Anbu. Especially during the design of hot water supply system, a typical example, like I have a 45-story building, and we have the equipment on the terrace level. It's all heat pump and all those things. So we have downtakes, and then we have made zones, and there is around 7 zones totally. So all the zones are supplied with hot water supply line, and then the return goes and joins to the reverse return. And that reverse returns goes back to the terrace level with a circulation pump during, well-designed circulation pump. So the question is here, when we connect all the zones, the hot water return lines to a common reverse return, which is going to the circulation pump, do you need any additional pumps at each zone level? Or if we design properly with pressure balancing valves and all those things, and can we do away with all the zone level circulation pumps, and we'll have one circulation pump?
First thing is that, when you're connecting 45 floors with a single hot water return pump, that itself is going to be a challenge. I mean, so even though you have your different zones, the heat loss, even in the risers, it's a substantial quantity. And the other point, which I think Mr. Sandeep also was touching upon it, to reduce the head as much as possible on the return pump. Because now in this particular case, what happens is that you need to compensate the heat loss for all the 7 zones. And your return is going to be, though you have a reverse return pipe, that is actually equalizing the pressures on the return lines. But still the water volume, it is going to be substantial. And having more pumps, and then again to have controls on how they are going to operate, is going to be more complex.
Big challenge.
Yeah. So instead of that, having since the system what you have got is a single pump from the top, and the return is going to, you need to take it back all the way up. So the only way is to have the volume, it's going to be a huge pump. Normally the return pumps are supposed to be small ones, but in this case, you will be having a huge pump, and also the, I would say the head also is going to be increased to handle all the pressure drops on the 7 risers. So, yeah.
No, actually, Mr. Anbu, at each zone level, when the return line connect to the reverse return, we will have a flow and pressure balancing valves. So at every level, we balance the pressure and then balance the flow. Of course, the flow will be almost constant, and then the pressure, say for example, if I want a a pressure of 2 bars at or 2 kg per centimeter square at the return line, I'll balance at every zone level, and then the constant pressure, and we keep increasing as we go up and up, the upper zones, so that at the terrace level, the pressure in the reverse return line will be not more than 2.5 to 3 bar pressure.
Yeah.
And then the pipe sizes will be calculated as per the flow. So I feel this works, and then we
it works. I mean, as I said, the volume, but the volume of water, the return water is going to be substantial because handling all the 7
zones.
So that is the challenge, because, and how long this pump is going to operate. I mean, are you going to have thermostatic mixing valves? The operation of these pumps, how you are going to control it. So
yeah, it will be with the each level we have thermostatic valves at each user's point, and then that will be on the flow switch, and then the pressure switch operated pumps
the header
at the top of the floor. So that will as the flow is there, it will operate for a fixed time, and then it will switch off and all those things.
Fine. Since you are having,
some
Rajiv, can I?
They were arguing.
Rajiv, can I?
Sorry.
Rajiv?
Yes.
Can I take 1 minute?
Yes.
Yeah. Okay. You see that I must congratulate one thing, that this hot water topic, especially in high-rise building, is really a very pertinent topic, because most of the people they do it by going to thumb rules or something like that. This is very, very important, that what has been said by speakers, that we should implement certain design standards. In India, what we find out, the selection of the material is a very, very important thing. We used to use copper pipe, as one of the learned speaker has said, but because of the cost and the fittings and certain problems, right, it is shifted to the PPR pipe about 10-15 years back. But the PPR pipe quality, I tell you that that 90% at the joint start giving up, and that it was discouraged. After that, this CPVC pipe, because GI pipe, which some people were using, got corroded. Now CPVC pipe is another material which is mostly used now in India. But again, the temperature, I mean, if it goes more than 70 degrees centigrade, then the whole joint start, giving up, So I think that maintenance of temperature, and then again, you see that the selection of the material is very important to maintain the harmony between the things there, Still, the selection of the material in India is a big question, let me tell you at the moment, and we need to address that thing there.
I think at this stage, Anbu, I think we'll have to stop this discussion here. And I think this subject is so interesting, we should have another session, I think, with the learned people, because hot water return is a big issue. I promise the viewers that we will be having another session shortly. Now we go into Firas Al-Nijar. He is a specialist in Middle East markets for plumbing. So the subject is apt for him, which is risk analysis in plumbing systems. As always, our sessions are interesting, so we are overshooting the time. My mobile is flooded with message from Sona. Over to you, Firas.
Rajiv, I need to share the screen, please.
Sonam.
I think everyone see the screen?
Yes.
Okay.
Make it full screen.
Yes. This is design criteria and system and risk analysis. Design criteria between different subjects. You have typical floor residential, as shown in the pictures. This is normal design for any building, typical floor, shaft, continuity roof. And we have building mixed use with hospitality building in the middle, as shown in the pictures. This is very difficult to use it, the MEP network within this type of this building. Challenging design of vertical pipe installation and material. Continuity of shaft till roof to accommodate drainage pipe. like type of this is building, it's very difficult to create shaft within this is building. Distribution of water supply network, transfer domestic water pipe or vertical pipe, pipe stress analysis and installation for expansion, contraction, and dilation of the pipe. Now, this is screen photo. We have absolute methods. It's passed from Dubai or the technologies, loop, expansion loop or expansion joint within the vertical pipe, installation within the riser. Now in the technologies, we have clamp riser with spring, floor by floor. You can install the vertical pipe only with this is clamp. Don't use anchor support or clamp within the running pipe in the riser. Only clamp riser to avoiding stress analysis, stress the pipe or expansion the pipe during passing the hot water within the pipe surfacing inside. Material, pipe material, and type of fittings for the riser. Especially for high rising, always use stainless steel pipe, groove type, and fittings till BRV stations, as this is type of pipe to avoiding expansion, contraction, and deflation up and down. Pressure reducer valve installation. We have seen a lot of engineering design, location of the BRV station strongly as shown and the line here. I see a lot of drawing coming to me from the engineering designing install BRV within the vertical pipe to maintain the pressure within the vertical pipe. It's completely high risk to maintain the pressure. Another installation, it's also risky. One BRV surfacing 3 floor. And this is to type, both of them, this is have to use pilot type BRV. And this is not direct acting and will not maintain the pressure properly in the high capacity. Recommended solutions, use floor by floor BRV stations to maintain the pressures and direct acting pressure reducer valve. Don't design the BRV bypass installation valve assembly, because if you open the valve, you maintain the pressure both sides and will make it big issues in the fixtures in the kitchen and bathroom, broken water heater, everything. Always use dual or single BRV stations for the branch floor to floors. How I can accommodate the drainage pipe in the shaft? How I can give design relaxation to architect drawing during changing of layout. Sometimes we have hotel part and end of the floors of the hotels coming ballroom or restaurant, and we found our shaft during the hotels. I cannot continue to roof to pass the drainage pipe. My recommendation from day one of the project, use the core of the building. Take it relaxation to connect all the vertical, horizontal run pipe and the vertical pipe. Found solution for these cases below. If water flood in the floor or in the main corridors. If the 6-inch water pipe broken within the floor, if the hose reel or firefighting system is activated. Question: what is hose this activity happened in the high-rise building? there will be a lot of damages in the lift, ceiling, light, wall vent, etc. because of water. Solutions. To avoiding any water going through lift, shaft, or staircase, slope level, floor level corridors to garbage room, as shown in the pictures. Create 6-inch floor drain in the garbage room, as shown in the picture. Cut the garbage room door 3 cm from bottom to allow water go through the door. Using metal pipe or cast iron pipe only for this is floor drain. Why? I give you our experience during big fire happened in the Dubai here during New Year, one New Year. We found all the pipe, PVC pipe, it's melted. During this is fire, the PVC pipe will be melted because of heat. Thank you. Any question?
Thank you very much, Firas. Thank you very much, Firas.
Thank you, Rajiv.
Well covered pipe stress analysis, pipe materials and types of fittings, PRVs, location of drain pipes. Just for the information of my MKG and BSA Narayan, if you remember the project you visited in Dubai during our World Plumbing, the address Sky View, where you were all impressed with the design, that has been done by Mr. Mahendra and Mr. Firas. And the project is completed and the whole building is running now for the last 1 year. Just to recap on your memory.
Oh, yeah.
Yes, it's been.
Congrats.
Okay. I think we will address the questions towards the end of the session because of the timings. Now we have taken care of all the water, everything inside the building, the pressures, everything is covered. Now comes the challenge on taking the hot water out, the wastewater, the soil waste and everything, the drainage solutions. May I now invite Sandeep Goyal to touch this subject.
Thank you, Mr. Rajiv. I hope my slides are visible.
Slides is visible.
Is it visible, sir?
Yes, perfect.
Thank you. I think it's a great opportunity. Different geographical locations, we all are sitting, collaborating. And in fact, I should compliment the IPSC team. Actually, this is a 5-subject webinar. Water supply, hot water, drainage, risk, execution. All of this multi-starrer, movie has been brought into one package of 1.5 hours. And I think this is where IPSC comes, where they not only talk about skilling the plumbers, but they're talking about skilling the professionals. When you have senior colleagues like Mr. Narayan and Mr. MKG also having their questions put to this panel, it only means that the professionals are also gaining so much of, they are also getting skilled through this reach. And that's, I think, the uniqueness that from plumbers to professionals, the opportunities for everybody here. Starting on it, before I really start on the drainage part of it, I would like to just talk about the hot water for 5 seconds. Most of the times people do not understand thermostats very well. And if a thermostat is like a, it's like a, car with an ABS as well as with all kind of airbags and all kind of systems provided. If the consultants make mistakes in their design planning, the thermostats will never give you the kind of efficiency which they are provided for. So possibly we can talk something about thermostats in future, because that's another topic of interest. If we are able to handle it properly, it will give you the right results. So that's something which we can look at as our future planning. One of the other webinars we can talk about. Today, talking about the plumbing systems in high-rise. While water has been talked about in great detail, one of the things which I feel personally is kind of ignored by many designers or the end users, contractors, is the drainage part of it. So I'll just cover quickly 1 minute in all the 5-4 topics. Terminal velocity, stack sizing, vent sizing, horizontal transfers, and rainwater. Now, all of these 5 subjects are very critical if you talk about high rises. So most of the people would focus about water supply, zonings, pressures, minimum pressure 20 psi, maximum pressure 80 psi, and the provisions of the PRVs. But now let's get into the part of working on the drainage part of it. So on a drainage pipe, Mr. Narayan is also one of, he is the chairman of the National Building Code of India, Part 9, 2016. And, all of us worked together along with Mr. NKG, myself, and some of the other colleagues, Mr. Vinay Gupta. We tried to work on the National Building Code, where we have included the concept of educating the reader about the planning only, the designing of the drainage pipe. If you read most of the codes, they do not teach you designing. In this case, a lot of stakeholders from IPSC were part of the NBC, and a lot of detail has been provided. So the drainage design, basically, it acts like a college graduation, engineering book, which actually explains how the water goes to the periphery of the stack, and the center is the air core. Now, when this water is accelerating, then we call it something like a terminal velocity, where beyond a certain point of time, the sheet remains unchanged in thickness, and it goes up to the bottom of the stack without having the increase in the velocity. Now, there is a certain distance beyond which there is a terminal velocity which is attained, which is predominantly to do with the gravitational forces and other aspects. So once the terminal velocity is attained in a vertical stack, your flow of the water or the liquid is in the pipe wall. The center has the air core. The vertical to horizontal header has something which we call as hydraulic jumps in hydraulics. So we do not really consider that to be a high pressure terminal connection. The point over here is, the most important thing to realize is, when the liquid transforms its position from a vertical profile to a horizontal profile, we do not experience a typical pressure, what we would think of in a typical water supply system, which is governed by the static head of the water flow. Here, because the water is this drainage has already reached terminal velocity, you don't experience pressure, but what you experience is a hydraulic jump. That means a jump beyond which the liquid backflows into the vertical section. Now that jump is classified as 8 feet, 2.4 meters. So 2.4 meters, what you see on the vertical and the horizontal profile, are the most critical zones where the hydraulic jump is tremendously experienced. So what the code recommends is that in a high-rise building, if you have that scenario, these zones are your no-go zones. That means, technically speaking, you cannot connect any of your connections within the profile of 8 feet from a vertical to horizontal transverse, which is happening. So if you really look at a profile like this, you have got a vertical downtake and you have got a horizontal transverse. So once you are doing a vertical to horizontal transverse, you also have to look at how do you size the horizontal transverse to cater for the multiple shafts. So one of the hotels which we do in a high-rise building, if you have got one vertical stack coming down and there is another vertical stack which is coming down, and there are multiple of them happening, as you can possibly not be able to see in this picture right now, but the pipe is going longer. So you have to be careful about connections at the stack level, and also to size this network of pipe which is collecting majority of your vertical stacks. So now this is an engineered approach in a high-rise building, because most of the shafts are not in continuation, and we discontinue the shaft by providing a service flow transfer approach. So once you have a service flow transfer approach, one has to be conscious about the connections to the vertical stack and also the sizing of the horizontal pipeline. Another subject which is very essentially to be dealt is the vent pipe. Most of consultants, designers, professionals, we do not realize that as the building height is going up, you will have challenges if your pipe of the vent size is not engineered. So you have to engineer it properly so that the gases are able to also exit from the top of the building, because that is where, if you do not pay attention, your pipe can become undersized, leading to accumulation of the methane gas and therefore a possible explosion as well. And also the smell nuisance which will go around the building, you would wonder what is happening. But the problem is, if you have not engineered your vent correctly, you will have smell issues with the project, because your vents are not adequately sized to the height of the building for the dissemination of the waste nuisance, the smell which is going to be there generating from the discharge of the soil and waste. So another point is vent sizing. Rainwater pipes are another important areas of design in a high-rise. The roof areas are not very large, so you can also look at siphonic drainage system. But in our design, we always prefer for the rainwater not to be inside the building, but the architect has to work smart in ensuring that the rainwater downtakes should be planned in such a way that they don't come into the core of the building. So there has to be an articulated approach, because any pipe which comes in the middle of the banquet hall through a vertical pipeline, and if there is a problem there, it is uncontrollable scenario at 3 a.m. in the morning when it is raining heavily and the pipe breaks, or if there is a party going on, you can imagine it is beyond anybody's control to close that rainwater ingush into that public area. So that's why another important thing is that rainwater's roofs are smaller, but they could be a big trouble if they break inside the vertical profile of the building. And last but not the least, we always try to innovate without a strong foothold of codes and compliances. I meet many consultants, and when I see drawings like this, they always give a smile to my face when they say, Mr. Goel, we have planned to do innovation by providing velocity breaker. And I keep asking them, can you tell me any code in the world which prescribes the layout of a velocity breaker? And believe you me, I get drawings like this from many other consultants, colleagues, friends, innovating and trying to come out with solutions which probably never have a problem at all. Thank you, sir.
Thank you, Sandeep. Touching soil waste when rainwater harvesting and concluding with velocity breaker. I think that's an evolution today. Finally, we go to Sandeep Roy Chowdhury. He will be talking on a simple but very relevant subject, construction challenges in the MEP sector. And after his session, we would be having a question answer session and a discussion and the conclusions. For the information of the panel, we have about 400 people logged on through different channels, multimedia, Fiki Bike, etc., etc. So you are in midst of a good viewership. Thank you. Over to Sandeep Roy Chowdhury.
Thank you, Rajiv. As Mr. Sandeep Goel said, that skilling never ends, and really skilling never ends. Till the last day of our life, we will be getting skilled. And as I come from the Sonam, will you please share the slides? As I told that I come from a construction company and I head that company who is in contracting. So I will touch upon some points why and the challenges in high-rise building. Material handling is first point, manpower. And manpower, will start with material handling. That material handling needs to be well planned in advance. Location and access of the store is very important, and this is going to be dictate the ease of handling in terms of receiving, storing, and distribution. Circulation plan should be easy and simple. Logistic, including lifting arrangement, should be adequate to facilitate the transport of material in minimum time and manpower involvement. Accurate and precise day-to-day requirement should be well documented. The person responsible for material handling should not overlook the slightest material, because you can understand that in a tall building, if somebody goes up and the material he does not carry, the requisite material, and he cannot come back. He can come back, but it will be a waste of time and energy. And then I touch upon manpower mobility. Sonam, can you go to manpower mobility, please? We have finished material handling. Manpower mobility. Availability of passenger hoist is must for full utilization of manpower in high-rise building. Number of hoists should be adequate depending on the scale of the project. And now I go to
next
access. Next, Sonam. Proper and easy access to working areas is a must and should be accessible at any point of time during and even after completion of the installation. There should be arrangement to access not only the internal shaft, even the shafts that are accessible from the external face of the building. It is possible, if possible, access should be avoided for external facade. The size of shaft and arrangement of the services should be so planned that the workability be trouble-free. Next slide, please. Installation. This is most important part because at the end of the day, this is going to determine the class and reputation of the company. Installation should be easy, accurate, and flawless. I just want to share you some of the installation challenges which I have. The finish level of the flooring in toilet should be well coordinated to keep the soil line outlet. Otherwise, the height of the WC will not be proper. If there is a mismatch, and lot of rework need to be done after installation and finishing. The installation work should be properly tested, both the water and waste line installation progressively, even before the final testing and commissioning to make the commissioning process smooth. Quality control. Sonam, this particular is equally important for all sort of projects. Each step of installation should be documented. We must insist test certificate of all the materials used for high value mechanical items. Inspection in factory is preferred to check the performance as per the data sheet approved by the consultant. The construction team should undergo an orientation program that how their little mistake can be a big quality issues. It is important that the company should depute an independent quality assurance team on regular interval, and they should be independent of project team. Quality is the outcome of everyone's equal participation. Safety. Human life is precious, as we all know. That anything else on the earth. So safety is equally important for any kind of project, irrespective of its nature, size, or standard. But when we are talking about high-rise, safety becomes most critical. I would advise everybody to use fire sealant when the pipe pierces the wall, because during fire, it isolates the area and makes the building safe. Safety is a matter which cannot be achieved until and unless all stakeholders take it with most importance. Generally, it should come from top management. Workers should be made aware of the benefit of the which they normally consider as an additional burden. The workforce should go through checkup of health parameters before they are allowed to start work. Next slide is damage during construction. We often found that because of lack of synergy among the various agencies involved in the project, many things happen which could have been avoided. Adapting BEEP technology can synchronize the installation steps, and which can be planned beforehand and can mitigate the clash points of other services. In case of plumbing, this lack of synchronization is a big problem if not addressed beforehand. We find that after completing the pipeline in the toilet, tested and handed over to the next sequence of job, the tiler or other finishing worker comes in and during his work, punctures the line. The plumbers come at the end of the project, fix the fixtures, and commissioned, it starts producing damp in adjacent wall or ceiling, which costs money and time. We should be more careful not only to protect our own work, but also to work done by the other agencies. Generally, we pipelines and secured the open end with help of cap or masking tape. The part of the conceals flush tank and inner body of the diverter also been fixed beforehand. There are protectors with each such fittings and fixtures. But in many cases, when we go to fix the fixtures finally, we find that the cap or the protector are missing, keeping the end of the pipe or fittings open, and there are enough foreign materials inside damaging the installation. Most of the time, it costs while removing the tiles, rectify the installation. Next is maintenance. This can be the nightmare for installer or the person responsible for the same if the whole thing is not well planned. access to place is must at any point of time and should be free from all dependency. All should have an access door which should not be blocked under any circumstances. The developer must have a clear agreement stating that the access door cannot be touched under any circumstances. To my experience, I find most of the time for beautification, these are blocked, and this happens more often in the premium projects where the owners care more about the look of his apartment rather than engineering. And it must be remembered that you must obey the traffic rule, whether you own a car costing 5 lakhs or 5 crores, the rule is same for everyone. The next matter that we often face is clogging. Just before commissioning or after the building is commissioned. In the first case, we find that the people try to drain out construction slurry to wooden pieces, which subsequently solidifies and choke the line. This is to be avoided as far as possible. The occupants in such housing should also be made aware of the danger of throwing all kind of waste to pipelines. Presence of accurate as-built drawing is essential. This is very much important because the person who have built it and the person operating or maintaining it afterwards are most likely to be different. And finally, I come to my conclusion. It is very important to synergize all the activities and multifold logistic of material and manpower, including the planning from the very inception of the project for smooth and trouble-free implementation. Rajiv, I think I am within my time.
Perfect, Sandeep. Actually, thank you very much. And very well handled, from material handling to manpower to accessibility to installation to quality control to damages to maintenance. Thank you very much. We have 10 minutes where we can take any questions and then we move to the conclusions. So any questions? I see many questions here. I find many people from yesterday's panel discussion, architects versus MEP consultants here. Welcome. Thank you very much.
Rajiv, I need open topic. This is a grease separator within the bridge that between two towers. So always, the bridge coming as a restaurant or a swimming pool, or in the pool deck have a restaurant. Please implement grease separator or free door grease separator, automatic grease separator within this bridge, and discharge water pipe pump to sewer network.
Thank you. Any other questions, anybody? The panelists, would you like to say something to each other?
Mr. Firaz, I would like to know from you, when you say you are using groove fittings for stainless steel pipes, I find challenging for the pipe material to be suited for groove fitting with respect to manufacturing. I am finding it very challenging unless until I really. So on the groove fitting, what piping material is available from any international supplier?
We have a lot of supplier, China market or from Russian. It's stainless steel pipe 316L. It's casual 40 and casual 80. It's available in the market.
You don't get anything from Vega, or you don't get anything from any of the reputed manufacturers on the groove fitting?
In time being, I'm not in mind, but I can provide it to Rajiv, or I can, if you share your email, I can send it to all.
I think Mahendra has something. Mahendra has something.
Okay.
See, the stainless steel groove fittings, they have to be, you can't use the firefighting groove fitting for the stainless steel.
Yeah, that's right. That's right.
Victaulic has a special range of fittings to use on stainless steel. And right from schedule 10, you can groove them, roll groove the pipes. Any stainless steel, schedule ASTM, schedule 10 pipes, schedule 20 is like a schedule 40, 80, depending on what pressure ratings you need, you can use. Riser pipe work, a schedule 10 pipe, a 4 inches can take up to 35 bar with a properly engineered groove fitting.
Okay, we'll try to understand further about the availability of them. Thank you.
And the Victaulic pipes fittings are available in India, no, Mahendra, sir?
Victaulic is available in India. There are other makes are also coming up with.
I remember from Pune, somebody was there. We once looked at it.
Fitting, especially the couplings, they are again ductile iron. No need to go for a stainless steel grooved coupling.
No,
But
metallic couplings are available in India.
They have to be cast stainless steel.
Sorry, metallic couplings are available in India. We are using it in so many projects.
Who is speaking this?
Mr. NKG. Mr. NKG. We are using Victolic a lot on fire, but not exactly on water and water supply.
On stainless steel, you can use on copper also.
Yeah, that's
what happens. Copper piping 108 and 159 mm. When you go to table X, when you try to braze it, it gets annealed, and pressure rating for 159 mm pipe falls down to 10 bar. You can never use it on a riser. So by using a grooved couplers or grooved fittings of copper, you can maintain the hard drawn pressure rating of 15.6 bar.
Great. Any other questions?
Rajiv?
Yes.
Just adding on very presentation on Sandeep regarding the, when you put diverters into the wall, I'm just talking about as a bath fitting manufacturer. Yes, we used to have a lot of these problems earlier. It used to cover the chrome platings. Now, what normally all the diverters are coming is they're fully sealed in a box. They're all covered. I can just show you that what we all covered. Number one. Number two, Sandeep, another issue that we used to find is that when the round flange, it was fine. When people are using a rectangular plates, it used to come off-centric. So what we do is now every box, we give them a spirit level. So that, when it's fixed absolutely straight. And it doesn't give you a problem. Second goes your wall-mounted mixers. They will try and give you two spirit levels, one on the front and one on the side. So there is not even, either way, there is no problem. So the flange will be absolutely perfect. And we need to take a lot of preventive measures instead of then fixing and taking out the product and then moving it, fixing it. So
right.
As for what Mr. Sandeep Goel talked about thermostat mixers, yes, we would like to have one individual session because thermostat mixers were not used in India as much, but now is being used very, very extensively. And we have seen a couple of problems at certain places where because of design issues, there has been a lot of issues in the functioning of the thermostat mixers. Probably Sandeep, if you can have a topic on this.
I think yes, Vinay, because we're getting close to the time now. We have 5 minutes for the next session. So I think there's some questions from Chintan also. Thank you, Vinay, for this. I think we'll have a session on this, plus vent valves, plus TPR valves, plus vacuum breakers. There's questions from Chintan said. I think this session has helped us to analyze the need of practical courses like this, practical interactions between the MEP consultants and the contractors. I have time for one more question.
So slightly non-technical, well, I don't know if something that
you are asking, my God, I hope it's
I don't know whether it'll be the appropriate question or not, but when, are there similar tensions and challenges when we're designing a 600-meter tall building or designing designing and building 600 villas? I'm sure there would be differences, but are there similar ones as well?
There are no tensions, Varun. There's only excitement.
The pressures, Firaz and Mahendra, you like to comment on that?
The challenges on the mega towers definitely different because the building itself sways.
So, anything to comment?
Rajiv, I can
take it, like Mr. Firaz said, take everything into the central core. Sway would be the minimum.
Rajiv, can I say something?
Yes, please.
Yeah, the challenges are, the practically design challenges are same, but then application is slightly different. When you go for a vertical high rise, Varun, there will be a different challenge. And when you go for a horizontal spread up, there is equally a challenge in that also. So, like pressure balancing and distribution, complete distribution system and all those things. So, to answer Varun's question, in both the cases, challengings will be there, but there is no pressure or something. It's allowed to, you need to, you have to take that as a challenge and then allowed to do the things, allowed to do the design.
Great.
One question, I think,
Yeah.
Rajiv Saab, I just don't want to miss it. One of the questions Mr. Srihari has asked, how does the terminal velocity change with the building height? Does it keep increasing with building height? The answer to that is no. The terminal velocity beyond a height of the building does not change. It becomes constant because of the friction of the water which flows in the pipeline versus the gravitational flow. If you do a little bit more research on hydraulics, you will get an answer is no. Anything which you further need, IPSC will be glad to supplement replies.
What happened to Burj Khalifa?
Rajiv, I'm sorry, just I'll take half a second. Terminal velocity will be attained in a vertical riser pipe, approximately, within 2 to 3 floors, depending on the size of the pipe, whether it is 4 inches, 6 inches, or something like that. The terminal velocity will be attained in between the 2 to 3 floors. When it attains the terminal velocity, and that will be constant till the last floor, where I think Mr. Sandeep Goyal has shown a sketch, which is very clear. So it will never change. Terminal. There was a very, very basic question wherever you go and present this kind of things. Oh, during a 40-story building, you need to have a pipe, it will not break at the bottom and all those things. It will never, that's a myth. It will never break. It will never deviate from its path. The velocity is same, it's constant.
Thank you, BSA. I think it's time for us to conclude now. The objective of this Plumb Expo plus all the sessions is conclusions. We had our Indo-UAE roundtable, we had conclusions. As I told before, yesterday we had the MEP versus consultants. Arguments were fierce, the panelists are here. The conclusion is simple. We didn't reach a conclusion. But the conclusion by the moderator, which I'm reading here, is we must build the timeless way. Architecture must be focused on being local and the process driven by a collaborative approach to bonding between architects and consultants. Sustainability must be intrinsic to the nature of the existentialism. The future is architectural engineering. So that was the conclusion of yesterday. Today we had sessions with the think tanks of the industry, the professionals, and I think this is the starting of many similar sessions in Middle East and in India, and to have a club of the design think tanks, be it consultants, be it project managers, be it contractors, to ensure a good global plumbing educational forum. Today we started the session with Mr. Mahendra talking on the upfeed and the downfeed, where he connected the selection, the aspects of water hammer, the effective start and stop. And in downfeed, he stressed the importance that it shouldn't be more than 5 bar, suitable PRVs, and avoiding VF and advocating VFDs. There should be a knowledge sharing. Mr. Anbu touched the subject of hot water return in high-rise buildings, where we touch pressure balancing, temperature balancing, the Legionella Stratification, the pressure rating importance, the expansion and contractions, and many other challenge of ensuring constant hot water supply, especially in hotels and hospitals. Firas touched on the subject of risk analysis, where he stressed on pipe stress analysis, pipe materials and type of fittings, PRV, and the location of vertical drainage pipes and water flooding, with some very good presentations. Sandeep Goyal very efficiently took us through soil, waste, vent, and rainwater. And Sandeep Roy Chowdhury presented the construction challenges, material handling, manpower, accessibility, installation, quality control, damages, and maintenance. So I think in totality, the session was very well done, very well handled, and the experts have done a phenomenal job. With this, I would like to thank you, and I would like to have the concluding remark from Mr. R.K. Somani, our mentor. And He has a throat problem. I'm sorry. So I will pass it on to Mr. Vinay Gupta for 1 minute for a conclusion.
Thank you, Rajiv. An excellent session, and couldn't be better. And so many interesting topics have come out of it. And I feel we should have a bit more often and very regular such kind of meets, which will be very, very good for the industry. And we would also want the consultants from the Middle East other to be on our IPSC advisory council that we have got, and it will be a great learning from all of you together. Thank you so much, and sincere thanks to all the panelists today. Thanks, Rajiv.
Thank you very much, one and all. It was a big challenge to get you all under one roof. We had a lot of meetings. And finally, thank you very much because everybody has accepted the invitation, took time to be with us on holidays in the Middle East, and to the panels from India. Thank you, IPSC. Thank you, Fiki, for giving me opportunity for organizing this international seminars. Thank you. Good day. We'll send you the conclusions by mail.
Thank you, Rajiv. Thank you all.
Panelists can say one word and before we close. Sonam has said 1 more minute.
Thank you, Sona. Thank you very much for managing us all well.
Anbu? Firas?
Thank you very much.
Perfect.